Hello, hello, good
Hello,
afternoon, good evening, good morning, all.
good
We will
afternoon.
start, we will start our session next 5 to 7 minutes. After few more presenter or session chair will join us.
Okay, thank you.
Okay.
Hello, good afternoon.
Hello. Good afternoon,
Uh,
sir. Yes.
uh, so I'm the presenter for actually this session. I want to actually share my document and start my presentation.
Yes,
Uh,
sir. We will start our session. After that, you can present, you can share the screen, sir.
Uh, s- so can I do it now?
No, no, sir.
Yeah.
Just a minute.
For sure.
So, hello everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 4C. Myself, Ritik Gohel, and this session will be moderated by me. So, on behalf of Global Knowledge Research Foundation and GR's Holistic LLP, it is my great pleasure to welcome you to the ninth World Conference on Smart Train System in System Security and Sustainability, WS4. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom today and tomorrow, that is the 20th and 21st August 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have six presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer. On 10 minutes, I will raise a gentle reminder to conclude your presentation. And there is another request to all the participants that you all connected with us till the closing remarks. And if you have any query and update, let me know in the chat box. So just before we get started, I would like to invite our session chair, Vaishali Rajput ma'am. So Vaishali ma'am is a Vaishali ma'am is a sorry ma'am. Hmm. Yes. Is an assistant professor in the Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Technology, India, with over 20 years of academic experience. Her expertise lies in the field of AI and data science, and she is an active professional member of data science. We welcome you, ma'am, in this session.
Yes, thank you, Riddhi.
Yes, ma'am. So I would like to now start with our first presenter.
I'm the first
Yes,
presenter, Miss.
yes.
From
The first presenter is Windy, and the
yes,
paper title is a digital shift in assurance: how
yes.
ESG disclosure and sustainability practice drive audit quality. Yes, you can, ma'am. You can start the presentation, ma'am.
Okay, thank you. Wait a minute. Okay. Good afternoon, distinguished professor, fellow researcher, and estimate participant. My name is Windy Permata Siono from State University of Jakarta, Indonesia. It is a pleasure and a honor for me to present my research entitled Digital Shift and Assurance: How ESG Disclosure and Sustainability Practice Drive Audit Quality. Hmm. And then in introduction, let me begin with the context of business transformation. Digitalization is reshaping how audit and assurance process are conducted. With advanced tools, companies are now evaluated not only on financial performance but also on broader measure of accountability. This brings us to the importance of ESG disclosure. Regulator and investor increasingly demand greater transparency, making sustainability a critical indicator of corporate accountability and trust. From here, our main research question arises: how do digital assurance and ESG disclosure work together to improve audit quality? This question guide the core of our study. In the literature, we first look at ESG disclosure and audit quality. ESG disclosure is shown to improve audit quality by enhancing transparency, reducing information asymmetry, and providing auditor with better insight into organizational risk. And the second, we consider about sustainability assurance and audit quality. Sustainability assurance through independent verification ensure the credibility and reliability of ESG report. The strengthens stakeholder trust, reduce audit risk, and support more reliable auditor judgment. Overall, both of ESG disclosure and sustainability assurance emerge as a key drivers of audit quality. And the next, we consider audit technology readiness. This refers to the ability of auditors to adopt tools such as data analytics, AI, or artificial intelligence and blockchain. High digital readiness enable to comprehensive risk assessment, smoother ESG data integration, and more accurate evaluation. Most importantly, it amplified the impact of ESG disclosure and assurance on audit quality, ensuring audit more reliable, efficient, and future-oriented. Okay, based on the literature, we develop 5 hypothesis development. The first, ESG disclosure is expected to have a positive effect on audit quality. And the second, sustainability assurance also positively influence audit quality. And the third, audit technology readiness is proposed to directly enhance audit quality. Furthermore, hypothesis 4 and 5 suggest that audit technology readiness act as a moderator, strengthening the impact of both ESG disclosure and sustainability assurance on audit quality. Together, these hypotheses reflect the integrated role of ESG practice and digital readiness in shaping audit outcomes. And the research method, this study adopt a quantitative research using structural equation modeling with the partial least square method, and the sample consists of 100 professionals, including internal auditor and internal control function from both public and private sector in Indonesia. We use purposive sampling, selecting respondents with at least 1 year of experience in ESG reporting, auditing, or the use of digital audit technology. Data were collected through survey with measurement instrument adapted from validated scales, and then reliability and validity were tested using Convergence Alpha, composite reliability, AV, and discriminant validity. This study aims to provide insight on how ESG and digital transformation contribute to improving audit quality in line with supporting Sustainability Development Goals or SDG 9, industry, innovation, and infrastructure. And then in result and discussion, measurement model validation before testing the hypothesis, we first validate the measurement model. The result of the convergent validity test so all indicators have strong loadings, which confirm that the constructs are measured consistently. In addition, the discriminant validity result indicate that each construct is distinct with higher correlation within the construct than across construct. This demonstrates that ESG disclosure, sustainability assurance, audit technology readiness, audit quality are empirically separate concepts. Overall, this result confirm that strong reliability and validity, ensuring that the subsequent hypothesis testing is based on solid measurement foundation. And the next, reliability and validity. The result of reliability testing including conference alpha, composite reliability, AV, and decision. This result of reliability testing, including conference alpha, composite reliability, AV, exceed the minimum threshold, and likewise validity tests such as average variance extracted or AV and discriminant validity confirm that the constructs are distinct and well defined. And then next, R square, the value of the value of R square. Finally, the R square value for audit quality was 0.591. This means that ESG disclosure, sustainability assurance, and audit technology together explain about 59% of the variance in audit quality. Statistically, this represents a moderate explanatory power which is sufficient for interpreting the structural model. And then direct effect testing result. In this stage, we test the direct effect using bootstrapping method with 5,000 resamples. And then this allow us to evaluate PET coefficient, p-value, t-value, and confidence interval. A hypothesis is considered significant if the test statistic greater than 1.96 and the p-value are below 0.05. In the table 5, all three direct relationships are significant. ESG disclosure has a positive effect on audit quality with t-value 2.617 and p-value 0.009. And sustainability assurance also significantly improves audit quality with t-value 3.081 and p-value 0.002. Finally, audit technology saw the strongest impact with a coefficient 0.351, t-value 4.716, and p-values of 0.000. Overall, this result confirmed that ESG practice and technological readiness are key driver in improving audit quality. And the next indirect effect testing result. In addition to the direct effect, we test the moderating role of audit technology readiness. Using bootstrapping, a hypothesis is accepted if the test statistic exceeds 1.9842 and the p-value are below 0.05. In the table 6, both moderating effects are significant. Audit technology readiness strengthens the relationship between ESG disclosure and audit quality. And then it strengthens the relationship between sustainability assurance and audit quality with a t-value 2.489 and p-value 0.013. This result indicate the digital readiness not only improve audit quality directly, but also amplify the benefits of ESG disclosure and sustainability assurance. In summary, ESG disclosure positively improve audit quality by enhancing transparency, reducing information asymmetry, and supporting effective audit planning. And then sustainability assurance strengthens audit quality through reliable third-party verification of ESG data. And audit technology readiness play a key moderating role. And the first, enhance the impact of ESG disclosure and assurance on audit quality. And the second, enable advanced analytic, anomaly detection, and real-time verification. Direct effect technology readiness independently improve audit quality by increasing precision, efficiency, and evidence reliability. Overall, finding highlight the synergy between ESG practice assurance and digital readiness as a critical driver of future audit quality. Maybe together this finding highlight the synergy between ESG. And the last, implication, limitation, and future research. This study has several implications, and theoretically, it contributes to literature on how sustainability and digital audit converge. Particularly, it encourages audit firms to invest in digital tools and ESG training, regulator to integrate ESG standard into audit guidance, and organization to adopt transparent ESG reporting with external assurance. And then there are also limitations. The study sample limited and low generalizability. The study used only 100 respondents in Indonesia, so generalizability is limited because in Indonesia, only in Indonesia. And also self-reported survey may create bias, and then maybe future research could expand cross-country comparisons, maybe juga mixed method with survey and interview or case study, and then explore moderators like
Dear author,
culture,
sorry to
auditor
interrupt you,
ethics.
but I think so you have exceeded the time limit of the presentation.
Okay, auditor ethics and organizational culture. To conclude, this research show that integrating ESG practice with digital readiness is essential for enhancing audit quality in today's fast-changing environment. Thank you very much for your attention. I look forward to your feedback. Thank you.
Yes, it was a nice presentation. Just one question from my side, that you have mentioned about the R square values in the result part, right?
Sorry, Miss.
Uh,
Pardon.
you have mentioned,
Can you repeat your question? I can or more slowly. I cannot
yes,
understand what you say.
yes, I said your presentation was nice. I have one query. Uh, that in the result part, you have mentioned about the R square value.
P value.
Yeah, that R square value you have mentioned, that was 0.591, something like that. So how do you interpret this, that it is giving you a good result? How you will explain the power of your model with this value?
Maybe in
Which slide?
And previous slide, previous slide,
previous slide in this slide.
previous to this.
In this slide.
Yes, this was your value, R square value 0.591. So how will you elaborate that this is giving you good result?
R
About
square
R
because
square,
this is R square and
yeah.
R square adjusted. And then R square wait R square is 0.591, and then this means that ESG disclosure, sustainability assurance, and audit technology together explain about 59% of the variance in audit quality. This represents a moderate explanatory power, which is sufficient for interpreting the structural model.
Okay, good presentation. All the best for your work.
Okay, thank you. I'm so sorry.
Oh, it's was good. Correct answer.
Okay, thank you, Miss.
Okay, thank you. Thank you for the presentation, ma'am.
Okay, thank
So
you.
moving to our next presenter, Next presenter is a Mohammed Amin Obat. And paper title is Enabling Intelligent Recyclability Assessment in Additive Manufacturing, a review of key matrices and influence parameter. Hello, sir.
Hello, good afternoon.
Yeah.
So can I start?
Yes, sir. You can start, sir. Yes.
Good afternoon, everyone. Today I'll be presenting my paper on enabling intelligent recyclability assessment in additive manufacturing, uh, a review of key metrics and influential parameter. This paper is a result of the work done by me, Mohammed Amin Obuhat, and Dr. Nasser. So the presentation will cover the following topics: introduction, methodology, recyclability assessment metrics, the influential parameters, predictive tools, and also at the end, we are going to propose our methodological framework, and at the end, I will provide the conclusion. So, the global plastic waste crisis is rapidly increasing, with projections suggesting it could reach 710 million tons by 2040. So additive manufacturing contributes significantly to this problem, to its waste generation. However, AM also offers a role in thermoplastic recycling. So as you can see in figure 1, there are 4 types of thermoplastic recycling method. So our focus in this research is on secondary thermoplastic recycling, which is related to the additive manufacturing. So we are focusing on material extrusion additive manufacturing, uh, and specifically we are working on the fused filament fabrication method, which by using this method we can uh, produce our uh, our manufactured part layer by layer. So the challenge is that, okay, the global plastic waste is increasing, and also uh, actually the additive manufacturing waste contributes to this problem. So what's our solution? So the solution is try to recycle this additive manufacturing waste by using the secondary recycling process, which they name mechanical recycling process as well. So our goal is to convert the additive manufacturing waste into reusable printing filaments. So as you can see in the figure 2, ABS is a primary contributor to additive manufacturing waste. So ABS is the second most common recycled polymer in actually additive manufacturing. So, and also you can see that AM waste primarily made up of ABS is not widely recycled, with less than 10% of the waste being reused. So in this section, we examine the challenges of a conventional recyclability assessment method, which are time-consuming, costly, and not environmental sustainable. So we are going to propose a framework to actually make the recyclability assessment more efficient. So after proposing the framework, We will reduce the practitioner's knowledge burden by offering intuitive tools for evaluating recyclability. So also by developing this method, the recyclability assessment will be cost effective, more sustainable, and easy to use. So to do this, we did a systematic literature review to identify the key recyclability assessment metrics and also the parameters that influence these metrics. Also, we explored the deep learnings methods that helps us to predict the recyclability actually helps us to predict the quality of the additive manufacturing parts. So what is our methodology here to do this literature review? So as you can see here, we adopt the PRISMA approach. So the PRISMA guidelines helps us to define the database sources and also the search strategy, establishing the study inclusion and exclusion criteria, and also setting a study selection procedure for eligibility assessment. So step by step, we are going to filter out the papers that we identified until we end up with the primary study that we are going to work on and review them very in detail in this actually research. So we define our data set, which is the Web of Science and Scopus, and we search journal papers that published during 2005 until 2025. Also, we define some actually keywords and also the criterions which is related to our uh, research. For example, one of them is it should be thermoplastic, or the thermoplastic should be recycled, and then try to evaluate its quality. So by this way, we gathered around 350 papers, and then by 3 stages, we filter it out to the 36 papers, which is completely related to our topic. So now we need to quantify actually the degradation of the material. As you can see in the figure 4, there are different type of properties, material properties, characterizations. So to quantify the degradation, we need to measure these actually material properties. For example, thermal properties or the mechanical properties are very important, and how we try to quantify them by using the techniques that you can see in the picture. For example, mechanical testing or hardness and surface testing is related to measuring the degradation based on the mechanical properties. So the first step is to identify the recyclability assessment metrics. So, as we know, mechanical recycling introduces shear stress that cause thermomechanical degradation of the material. So mechanical properties such as tensile strength, elastic modulus, and elongation at break are very important for assessing the effects of recycling on materials like ABS. So, for example, as you can see in this slide, different researchers try to find the effect of actual recycling on mechanical properties, the mechanical assessment metrics. For example, one of them, Mishra, reported that the 90% reduction in the tensile strength. So we know that the most important metrics that can help us to understand the effect of the recycling on the mechanical metrics are tensile strength, elastic modulus, and elongation at break. So also the thermal assessment metrics. The mechanical recycling of ABS waste into the filament, so exposed into the high temperature, so which expose actually the material to the thermal oxidation degradation. So to measure this actually mechanism of degradation, we need to do experiments to measure a specific type of metrics, the thermal assessment metrics. So the most important thermal assessment metrics are glass transition temperature, decomposition temperature, and the yellowing index. For example, you can see that Mishra or also Forio try to measure these actually thermal metrics to investigate the effect of recycling on the material properties, specifically the thermal assessment metrics. Same for rheological assessment metrics. Also, recycling will affect the rheological properties. How we quantify this degradation by measuring melt flow index. So the melt flow index, or MFI, is the most important rheological assessment metrics, which helps us to assess the recyclability of ABS. So, for example, Turco observed a significant decrease in MFI before actually recycling and after. The last assessment metrics is chemical assessment metrics. So as you can see, the molecular structure and also discolorations serve as a key indicators of chemical degradation. So how we can measure this type of degradation? By measuring number average molecular weight, weight average molecular weight, polydispersity index, and the yellowing index. These are the most important metrics that we can use to assess the recyclability of ABS. Different researchers also investigate recycling based on measuring the chemical metrics. For example, Di and Yang found that the number average molecular weight, also weight average molecular weight, and polydispersity reduced after one cycle of recycling. Also, the yellowing index shows the reduction after one recycling process, which shows actually chemical reactions and oxidation during the mechanical process, during the mechanical recycling process. So the next step is to identify the influential parameters on recyclability assessment metrics. So by now, we identify the assessment metric itself. In this stage, we're going to just try to understand what are the influential parameters that affect these metrics. So the first group is design-related parameters of which is related to the printer, 3D printer. So the key design parameters affecting the recyclability are the layer thickness, infill density, and the build orientations. So different study was focused on find the effect of these design parameters on recyclability of actually ABS. For example, Fabro found that, okay, 20% increase of infill density will result in 61 increase in tail saw strength. Or
Sorry for the interruption, sir, but you have to complete in next 2 minutes, ma'am, sir.
for sure. Thank you. So this is, if we go on, we know that there are other type of parameters like process-related parameters that can affect the metrics. So the most important one are printing temperature, printing speed, and the raster angle. So also the number of recycling cycles are important, which will affect the recyclability assessment. So as we go on in different cycles, we will see that the material properties, the assessment metrics will affect after continuing recycling uh, uh, one by one. So now we are, and the last step is to explore the predictive tools. So as we can see here, there are two different type of actually predictive tools that helps us to actually predict the material properties. The first one is the deep neural networks. The deep neural networks is a very accurate tools that helps us to predict the quality of actually 3D printed part. For example, Yadav achieved, okay, the 4.5% improvement in the tensile strength of the ABS part using the deep neural network trained on infill density, extrusion temperature, and material density. Or the convolutional neural network as well is a very accurate tools that helps us do quality prediction and the defect detection. So for example, Zhang developed an CNN model for automated quality inspection in the metal AM. So we're going to propose our methodological framework. Our goal is to use deep learning models for automated recyclability assessment of ABS waste. So the key contributes are actually design parameters like layer thickness, infill density, and build orientation, and also the process parameters like printing temperature, the printing speed, raster angle, and recycling cycles to assess the degradation. What are going to be our outputs of our deep learning? The assessment metrics, which are mechanical, thermorheological properties, and also the visual, actually, uh, the visual properties like the crack distribution and the chart region are included here. So the data collection and the model training will be actually, as you can see here, we're going to use a dual training data sets that gather for failed print samples and support the structure, and also the image analysis, which gathered using the portable digital microscope to capture the degradation features. So DNNs for numerical attributes and CNN for image-based metrics are going to be used. So what are going to be the output? The recyclability classification. Performance threshold, for example, based on the application requirement, and also we're going to just define a recyclability score. So calculated using the weighted threshold. At the end, we're going to just know that, okay, for example, 80% is recyclable or 20% are discarded. So at the end, you will see that this is going to be our framework. So first we identify the metrics, assessment metrics, the parameter that affects the assessment metrics. Then we're going to try to generate our training data sets. So we will have two different data sets. One of them are going to be image-based data sets. Another one is going to be numeric data sets. We're going to use convolutional neural network for training image-based data set and deep neural network to train our numeric data sets. We're going to just try to use a data fusion to actually combine these two sources of data to actually have a very
Hello,
clear
sir.
single outcome as a recyclability classification score. So the conclusion, to conclude, we reviewed the literature on recyclability metrics for recycled ABS filament and deep learning techniques to quality prediction in AM. Also, we propose a framework for automated recyclability assessment of ABS waste. And also the future works will be the case study to validate the proposed framework and also create automated tools for recyclability assessment of ABS waste. Thank you for your attention, and I'm looking for your questions. Thank you so much.
Yes, sir, it was a good presentation. You have done a good work. I have one question from my side. Am I audible?
I can hear you, yes.
Yeah. In one of the slide, you have mentioned some MN, MW, PDI like this. So my question is that why does this recycling causes decrease in MN, NW, and PDI, and at the same time it causes increase in that alloying index? What is this significance, or what does this suggest in your work?
So you mean here, am I right?
Yeah. Yes, it's correct.
Yes. So as you can see here, after doing the recycling process, it will because in the recycling process, the material will expose to the high temperature, harsh shear stresses. So in the molecular structure, we will see the changes. These changes are going to show themselves in these type of metrics. So these are the metrics that shows, for example, the change scission happened or not, because we are dealing with the polymers. So the polymers has for example, the specific type of molecular structure. So by applying the high temperature and the shear stress, we will affect the structure, the molecular structure. So those changes will show themselves in these metrics. So we're gonna try to measure this type of metrics and changing by actually tracking the change in these uh, metrics, we will find out that okay, the degradation happens or not.
Okay,
For
good.
example, just to make it complete, for example, we will know that by decreasing in these metrics, it shows us that degradations are going to happen.
Yes. Yes. Okay. All the best.
Thank you so much.
Okay, thank you so much, sir. So next presenter is Pamela Ramirez Gonzalez, and the paper title is Renetes, a system for the timely monitoring of pre and post kidney transplant patients. So, hello, ma'am. Please start the presentation.
Hello, can you see my screen?
Yes, ma'am. We can say.
Great. So, hello everyone. I'm Pamela Ramirez. I'm going to present Renatus, a system for the timely monitoring of pre and post kidney transplant patients. This paper was made with 4 more authors. To begin with, transplants are essential when an irreversible organ damage occurs and no other treatment offers recovery. Transplants improve patients' quality of life and prolongs it, and we have three types: tissue, cell, and organ, and 2 types of donor: living and cadaveric. For 2022, 1,190 transplants were recorded nationwide here in Colombia. On the other hand, we have chronic kidney disease, which is a progressive condition that deteriorates renal function over over time and often leads to renal failure. In Colombia, chronic kidney disease represents a major public health concern, primarily caused by hypertension, cardiovascular diseases, and type 2 diabetes. The associated costs of this disease are estimated between 8.7 and 14.4 billion Colombian pesos annually. Therefore, there is where we have kidney transplants that it stands out as a common and selected treatment for chronic kidney disease, where it not only improves a patient quality of life, but also reduces patient related cost by 1/3 to health care centers. Nevertheless, the kidney is the country's most requested organ, where of the 3,663 Colombians that are waiting for an organ, 90.8% of them are waiting for a kidney. Transplant success, therefore, don't depend only on the surgical procedure, but also on the long-term patient care and adherence, where follow-up of immunosuppressive treatment, physiological variables, physical activity, diet, and education becomes crucial for patient success and health. Now we have mHealth and eHealth solutions where offer promising alternatives for improving patient engagement and reducing healthcare costs. And the existing solutions, such as the ones presented in Table 1, either target border transplant populations or remain disconnected from the specific needs of kidney transplant patients in Colombia, where they lack a platform combining educational resources and real-time IoT-based health monitoring. Now, talking about the healthcare institutions studied for transplant here in Colombia, institutions such as Colombiana de Transplantes, Fundación Santa Fe de Bogotá, and La Cardio provide educational material and guidance, but they lack mechanisms for real-time adherence verification or early warning detection. These solutions have as key aspects, they highlight patient follow-up, immunosuppression, patient education, physiological variable control, and patient general care. Here, we see a gap that raises a key question, that it's what are the characteristics that must have a digital system to effectively support kidney transplant patients in Colombia, promoting self-care and timely follow-up across all phases of their medical journey. That's where Renatus emerged as a response to this need, and to address the challenges faced by kidney transplant patients in Colombia, Renatus was conceptualized as an IoT-based system with an integrated educational platform for continuous monitoring and support. And the design emerged from semi-structured interviews with 6 healthcare professionals and 6 transplant patients, identifying medical, psychological, and informational needs across the transplant process, where the proposed solution has different aspects, such as the view of the user's profile, some general considerations such as accessibility, interoperability, and AI reminders. And it was think as system with different sections, such as physiological variables section, the medication section, the medical exam section, the educational section, and the medical appointment section. And another system focused only on healthcare professionals, focused in how to consult and alert them of their patient information. Now, talking about the system architecture, there were 4 main characteristics to create this architecture, where we have scalability, where we use AWS services that enable automatic scalability to handle different users and data uploads, high availability, where it was designed an infrastructure in order to ensure the system availability, cost optimization, where the module consists exclusively of pay-per-use, and agility in development, where Amazon Web Services were the best known cloud provider among the members of the project. So it was decided to continue with these services to accelerate the development of the project. Now, we followed a user-centered design approach that involved service with 43 participants, where 35% of them were healthcare professionals and 65% were patients from 15 different cities in Colombia. They were asked to rate the different functionalities proposed, and the patient's functionalities, the average ratings were between 3.6 and 4.8 on a 5-point scale. And for healthcare professionals, they rated all features between 4.5 and 5. Now, it was also asked about the usage intention of this system with those previous mentioned functionalities, and the usage intention was positive among 68% of the patients and 100% of the healthcare professionals, supporting the continuation of the development with prioritizing the highest rated functionalities for the MVP. Now, talking about the development, the backend was focused on the four main characteristic that I mentioned before, and the front end was developed in Flutter to create a multi-platform system compatible with different operative systems, and there was made an initial integration with a Bluetooth sensor, such as a tensiometer, to have the values of blood pressure. Now, to continue with the MVP for the patients finally gathered four different sections, one for physiological variables, another one for medications, one for medical exams, and the last one for educational resources. On the other hand, for the MVP for healthcare professionals, this was based on the consultation and alerts for the information that they gather from their patients. Finally, we had the evaluation and validation phase, where the users highlighted how they find the MVP user-friendly and the relevance that it was for them to use it as patients during their transplants process. And they highlighted how useful it was for them to control the medication throughout the system and to record and consult the data history of their physiological variables. Now, talking about the aspects that can improve, it will be the part of the medical appointment section, where they mentioned that it could be useful to have a calendar to see next appointments, and this MVP does not include this section. Accessibility and medical exam priority to upload different kinds of medical exams, and to customize medication in case prescription changes. In this survey, final survey, it was also asked for the likelihood of recommending this system to another patient, and it was rated 4.6 over 5. And in the case of healthcare professionals, it was asked the likelihood to recommend it to a colleague and to a patient, one of their patients, and these two received a score of 4 over 5. Finally, to talk about the state-of-the-art comparison, taking into account the 8 different solutions that were studied for this work, we have 3 different differentiation aspects from the 8 ones, that not all of them have the possibility to have serology tests, medical exams, and a gamification strategy in a system to a patient follow-up. And the fact, in the case of the healthcare institutions, that this is a digital tool, which is different of what they have actually currently in Colombia. And the fact that it differentiates us as we are based on Colombian population needs. Now, some of the aspects that are covered for most of the state-of-the-art solutions are the fact of medication and physiological variables control, and we cover these also in our system, and an informative and the fact that we have informative material in the system. And this is covered also for the 3 healthcare institutions that were studied. Finally, to talk about the system limitations, we have the fact that the system depends on internet connection, that the evaluation and validation phase was made on a focus group, and we have still manual data entry, and we are not yet integrated to electronic clinical history in Colombia, and the success of this system it depends on patient engagement. And to conclude, we have conclusions and future work for this system, where this paper proposes a system for the education and monitoring of transplant patients, and it looks to improve the interoperability with healthcare institution system that are currently working with. But it also gives us an initial overview of the next steps to continue with this project, and it was built with based on Colombian population needs, which gives us relevance to continue with this project. And we look forward for expanding sensor integration capabilities, not only with tensiometers, but also with thermometers and scales, and to expand to other types of transplant, and considering larger scale randomized controlled trials in order to get more feedback and get like a cycle where we have feedback and then we implement the new features based on that feedback. So thank you all for your attention and time, and I look forward to answer your questions.
Yes, Pamela, it was very nice presentation, and this is a very good step in case of healthcare professionals. One question from my side, that you talked about the app. Obviously, that app will be useful for the medical healthcare professionals. But in what terms patients will use that app? Means how it will be beneficial for patients?
Yeah, well, for patients, these, as we talked in the surveys and interviews, they actually are a kind of like a type of patients that are really engaged with their healthcare, because they know that if they don't have like a rigorous health health and control of their current health, it could mean the rejection of their organ. So they were the first ones to raise their hands and say like, okay, I want and I would like to have a system where I can see my progress, and where I can give my healthcare professional, my doctor, my nurse, how I've been evolving. And another thing that which they raise their hands, is about the educational material. They say, I don't know where to look for the information, or I lost the paper that the hospital gave me for my cares, for my transplant, and I lost it. So I don't know where to look forward for this for that information, and the system provides me like the information just in just in my cell phone. So that was another um, thing that they highlighted, that they find useful the system as patients.
Yeah. Okay. And how you collected the data set, through surveys or some any other way?
Through surveys or what? Sorry?
Data set, how you have collected your data set, through surveys or any other way?
It was mainly through service. Here they have like support groups for patients. So we collected our our data set based on the patients that were willing to help this project.
Okay, take good. All the best.
Thank you.
Thank you, Pamela. This is a nice presentation. So moving to our next presenter. Next presenter is a SM Ansahul Sarkar Akib, and the paper title is Smart IoT Egg Incubator System with Machine Learning for Damaged Egg Detection. Um, mm, okay. So next presenter is Chetan V. Pallikar, and the paper title is Startup Ecosystem and Role of Innovation Hubs in Regional Economics Growth of India. Hello, sir. Are you at the meeting?
Yes, I am here. Give me a second.
Okay, sir.
Am I audible, ma'am?
Yes, sir, you are audible.
Yes, so very good afternoon.
Yes, sir.
This is a new article. The title is Startup Ecosystem and Role of Regional Economic Growth of India. So, introduction. India's startup system has been incredible growth with the innovation centers playing a crucial role in local economic growth. These centers, such as incubator, accelerator, research institutions, etc., and the government programs like Startup India, Atal Innovation Mission have further boosted this revolution by offering the financial assistance, policy assistance, and the skill development initiatives. The influence of Innovation Center can be seen in the employment creation, investment, and the MSME development. So, the review highlights this review highlights the role of innovation centers shaping in entrepreneurial landscape and their broader impact on the regional economic development. So, the objective of study is to discuss the contribution of startup ecosystem in propelling regional economic development in India through the innovation, entrepreneurship, and employment generation. Second objective is to study the impact of policies and programs like Startup India, Atal Innovation Mission that have shaped startup ecosystem and the economic growth at a national level. So, the Indian ecosystem, startup ecosystem, the entrepreneur business or the newly formed business organization as a company, as a partnership, or temporarily entity with the objective of creating a scalable and respectable business model. And the government of India has taken several policies action counter the challenges of the entrepreneurs who seek taking the ability is ranked among the highest in the world. So this is all about system. The Startup India program has created huge excitement and offer huge opportunities for future economic development. India has identified the complexities and the dynamic nature of modern business environment. According to the study conducted by UK-based accounting firm says, IITs rank as the fourth largest producer of billion-dollar startup globally. The IIT alumni have contributed to the establishment of $12 billion enterprises, including the Flipkart, Snapdeal, Shopclubes, Zomato, etc. In the comparison, Stanford University got the landing position with the 51 such startups, followed by the Harvard University and the University of California. So these are component of ecosystem which developed by the Indian government and uh, uh, the the uh, the factors which is regulated for the developer ecosystem. So support organization, big companies, universities, funding organization, service provider, and the research organization. They are simultaneously engaged to make Indian startup ecosystem best. So the startup ecosystem is composition of individuals where startups and various stages of their life cycle and various organizations in the ecosystem. So there are major opportunities are found in the reviews. So first is the large population, where is the scope of large human resource and the large of intellectual minds. The connectivity, India's connectivity well around the world. Then the change mindset of working class. Nowadays, people's change their mind and they are ready to grow their self around the world. And the innovations now the youngsters uh, are very taking the interest to make innovative things, and they are ready to adopt their innovative idea to making a profit. So it is all about the opportunities of Indian ecosystem. Then the some challenges are found in my review. The cultural and awareness, as we know, the India have the diversities. So this the one of challenge, social issues, then the technological infrastructure, availability of technological infrastructures, financial issues, sustainability issues, and regulatory issues. These some challenges facing by the Indian startup ecosystems. So to avoid this kind of obstacles and make Indian ecosystem based, government of India taken some initiatives. So out of these, some policy initiatives and the developmental initiatives are the government of India enforce Make in India, Startup India. Screen is visible, ma'am.
Yes, sir.
Startup India, Digital India. These are the policy initiative taken by the government, and by this initiative, government of India try to stand up the business to start the business and encourage the people by financial support, by encouraging them by providing the knowledge, etc. As well as some developmental initiative taken by the government of India, like promotion of entrepreneurship, then easy doing businesses, funding and financial supports, innovation and research, and incubation and training. This kind of developmental initiative taken by the India So any innovation idea to develop into successful venture, it's required effective support, coordination, and guidance from the stakeholders and government and society. So this initiative made by the government. So now we are discussing about the innovation hub in India. The hub from the government and policy driven hub. Atal Innovation Mission started by the government, Atal Incubation Centers, Technology Business Incubators, Biotechnology Industry Research Assistant Councils, then SIDBI Innovation and Incubation Centers. This initiative taken by the government and make they made the hubs. Then as well as academic organizations also taken an initiative. So IIT Bombay made SINU, then IIM Bangalore, then IIT Madras, they made incubation cell, IIT Delhi, they made a foundation for innovation and technology transfer, and the IIC Bangalore Society for Innovation and Development they made, as well as the sector-specific hubs also exist in India, like as CCAM existed in the Bangalore, then NASCOM Center for IoT and AI, then TBIKIET Ghaziabad Engineering and Technology, then BRRSC BioNext exists in various cities in India, as well as some private and corporate entity also exist as a hub, like T Hub Hyderabad, Startup Village Kosi, Microsoft Innovations, Google Startup, etc., etc. These are private entities equally contributing to make Indian ecosystem based. So, what is the role of these innovation hub to make India based on make India economic power? So, these hubs playing a role to fostering the entrepreneurship, employment creation, technology transfer and communication, commercialization, the skill development and knowledge sharing, attracting investment and regional industrial development, as well as enhancing the MSME and startup. So conclusion is the innovation hubs are pivotal to India's regional economic development by promoting entrepreneurship, employment generation, and the technology transfer. These centers act as the drivers of skill development, investment attraction, and the industrial clusters, especially in IT, biotech, fintech, Startup India, Atal Innovation Mission institutes taken by the government further consolidated these ecosystems. With the innovation centers developing further, they make significant contribution to MSME development and regional industrialization going forward, strengthening the infrastructure, accessibility of fund, and the policy framework will be critical to support and build India's vibrant ecosystem for long-term economic growth and international competitiveness. So these are the references. Thank you.
Okay, Chetan, it was a good presentation. One question from my side. What do you think, which are the challenges that startups are facing in scaling from regional hubs to national or global markets?
Madam, can you repeat again? Your voice is breaking.
What do you think? What are the challenges that startups are facing in scaling from regional hubs to national or global markets?
But basic, as per my study, basic challenges is the allocation of resources, like financial resources. We should have developed our human resource power, and the allocation of the resources is mandatory. We have to work because people's really ready to you can say involve in the business, and they are ready to start the kind of things. They are really innovative, and the youngsters also taking the interest. But thing is, first their challenge is the financial things, as well as I said, the skillful labor, skillful workers, skillful labors. So these are the basic. I think in terms of India, this is the basic challenges. As I feel, ma'am.
Okay, yes. Good survey and good work. Keep it up. Thank you.
Thank you, ma'am.
Thank you, Chetan. So we are moving our next presenter. The next presenter is uh, the next presenter is a Fang Wang, and the paper title is Effect of Voice Enthusiasm in Social Robots on Children's Learning Performance and Emotions. I think she's an absent, so we can closing our session. So thank you. I sincerely thank our all authors for their excellent presentation and contribution in this session, and the participants for being a part of this international conference. I hope this session was informative enough. We on behalf of whole team, thank you for the support during this ninth version and the previous eighth version of this conference. We will happy to have you in the 10th version in 2026. All the presenter would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of Full Days for 2025. I also thank our session chair for chairing the session, Professor Vaishali Rajput ma'am. So here is the token of appreciation. Here is the token of appreciation from the GR team and the conference team, ma'am. Thank you for the valuable presence.
Yes, thank you, Riddhi. All the presenters, all the presentations were good. Wish you all the good luck for future endeavors. Thank you.
Thank you. Thank you, ma'am. So I would like to request to all, please turn on the camera for the quick snapshot of this virtual conference. Yeah. Yeah. Thank you. Thank you so much. Have a good day.